We're going to be talking about quadratic functions. Now, this will actually look a little bit familiar because we just finished our unit on factoring, right? So guys, a quadratic function is any function that can be written in the standard form, y equals ax squared plus bx plus c, where your a, b, and c are real numbers, and your a is not equal to 0. So basically, guys, we are very familiar with equations that have x squared, bx, and c. And so, y'all, these, because we just factored a bunch of these, right? So, guys, and so a just cannot be 0 because a quadratic function has to have an x squared in it. Does that make sense, guys? If it has an x squared, it's a quadratic. All right, guys? If it has anything bigger than an x squared, like an x cubed or something like that, it becomes a cubic function. So if the highest one is x squared, it's a quadratic function. All right? And the most basic quadratic function is this parent function, this quadratic parent function. Y equals x squared. All right, guys? So if you want to highlight it, you can highlight it. If you want to box it, you can box it. All right? And guys, the cool thing about quadratic functions is they have this lovely little shape. They're in a curve shape. Now this curve should look familiar because we would graph and check them, right, on our calculators when we were factoring. But this is particularly called a parabola. All right? So this particular curve is called a parabola. Okay, and parabolas represent a quadratic function. If you've ever heard something called like a parabolic curve, that's talking about a parabola. And guys, a parabola can go up, it can open up, and it can also open down. Okay, now something pretty cool about quadratic functions, y'all. I want you to take a look at this table. So we've already talked about linear functions and exponential functions. And guys, when we were doing with our linear functions, if we were finding the change in our x, what is happening with our x values for each of these right here? We were going up by 1. So we're adding 1 each time. And guys, the change in our y would be, what are we doing here each time? Ooh, to get from 4 to 1, what do we do, y'all?
We're subtracting 3.
Okay, to get from 1 to 0, what are we doing?
We're subtracting 1.
Okay, and now we're adding 1 and adding 3. So guys, is that a constant rate of change? No, right? With a linear function, it would be a constant rate of change. They would all be the same, right? That constant x with your constant y. But not with a quadratic function. But what I want to show you that's kind of cool about a quadratic function, guys, is let's look at the second change in y. So check this out. -3 to -1. What am I doing to get from -3 to -1? Adding 2. To get from -1 to +1, what am I doing? Adding 2 again. And last but certainly not least, to get from 1 to 3, what am I doing? I'm adding 2. All right? So what do we notice about this second change in y? That is constant. So y'all, the difference between linear and quadratic functions is there is a constant change in x with your second, change in y. All right, guys? There's a constant change in x with that second change in y. And so that is what tells us it's a quadratic function. So actually, you would be able to recognize a quadratic function just from a table. But now let's talk about all these important features of a quadratic function. Okay? Probably one of the most important things that you can identify, y'all, is the vertex. Okay? So if I was going to take a look at my little graph right here, my vertex would be the point where your parabola changes direction. Okay? And guys, this is super important. It is a point. Okay, recognize it is a point. Your vertex is one point. It's either the lowest point or the highest point on that graph, right? And then we're going to take a look, and through the vertex, there's something called your axis of symmetry, okay? And we kind of shorthand that to be AOS sometimes, okay? Now, guys, my axis of symmetry is the line that goes right through the vertex, and it cuts your parabola exactly in half, into two symmetrical halves, actually. And y'all, this is really important. Your axis of symmetry, it's an equation. All right, y'all? And the equation looks like x equals a number. And the number that it's equal to is the x value of the vertex. Okay? So that would be the x value of the vertex. All right, guys? So your equation, that number that it's equal to, is that x value of your vertex. All right? So that's super important. Your axis of symmetry is an equation. It's not just a number. It's an equation. All right? And then we also, okay, we talk about these roots, zeros, and x-intercepts. So, y'all, these are three things that are all exactly the same. And so, they are where the graph hits the x-axis. And guys, the acronym that I like to use for this is ROCKS. The roots, the zeros, and the x-intercepts are all the exact same thing because math rocks, right? Ha ha ha. So, if I ask you for the root, it's the same thing as the x-intercept. If I ask you for the zero, it's the same thing as the x-intercept. Does that make sense, y'all? Y'all tracking? Okay. Now, so that would be our roots, our zeros, and our x-intercepts. And those are written out. That's 1 or 2 points. All right, guys? That can be written as 1 or 2 points. All right? And it's written as an x0. Okay? So I'm going to go and do this, x0. Sorry, we got some stuff here. I got different colors going on. All right? Now your minimum. All right, so let's take a break here and look at our parent function. So guys, this right here would be my vertex. Are y'all comfortable with that? That's the vertex. This little orange line right here is my axis of symmetry. All right? It cuts right through the parabola here. Now guys, you will either have a minimum or a maximum. So looking at this example parent function right here, my y equals x squared, does it look like my vertex is a minimum or does it look like my vertex is a maximum? Okay, why do you say minimum? Okay? Because it's the lowest point in the graph, not just because it's 0. A minimum is when it's the lowest point in your graph. So if it looks like this, okay? Your maximum is when it's the highest point in your graph. And guys, your minimum and your maximum are directly connected to the y value of your vertex. Okay, guys? Your minimum and maximum are directly connected to that y value of your vertex. Now, for domain, these are all things we're going to identify about these. For our domain, y'all, the domain is any possible number, any possible x value. Okay? That's important. Any possible x value. And guys, it's going to be all real numbers. Okay, for the following graphs, they're going to be all real numbers. Okay, y'all? Unless we have a specific point where it stops, it's going to be all real numbers. The one that you're going to have to pay attention to is the range, right? Because remember, domains are your x values, range is your y value. And y'all, if it's an upward graph, if it's a graph that faces, that, makes a little smiley face, then it's the lowest point, right? And your y is greater than the minimum. Oh, what's going on? Not spelling words. That's what's going on. Sorry, y'all. Hold on. Minimum, right? If you have a downward graph, right, that goes like this, then it's your highest point. So y is less than your maximum. Do y'all feel good about that? So if you have one that is a downward opening graph, its y is less than your max. If you have one that's an upward facing graph, its y is greater than your minimum. So we're going to identify these fun things about these three graphs right here. Yes, ma'am. Go for it. Okay?
I have a question.
So, yes, sir. What's your question?
What if it's sideways?
Okay, so if it's sideways, it's not a parabola. So you mean like if it looks like that?
Yeah.
Okay, if it's a sideways graph, it is a parabola shape, but it's not a quadratic function. It would be a square root function, and it would actually not be a function. Square root functions are only like the top half of the parabola or the bottom half of the parabola. Okay, so good question there, Braden.
And it's always going to be like a straight line, not like squiggly or like...
It's always going to be a nice even curve like this. Yeah, just one U shape. Okay? So, or a consistent curve. All right, so guys, on these following graphs, let's identify some things, okay? So I'm going to zoom in, and we're going to talk through some of these, okay? So on this first one here, what is the vertex of this very first graph?
1, -9.
Very good. 1, -9. Okay? Are y'all good identifying the vertex? That is the point where it changes direction. Okay? Now, looking at this graph, y'all, is this, once you identify your vertex, we can use the vertex to identify our axis of symmetry. So, guys, what is the axis of symmetry? X is equal to 1. So, y'all, remember, it's not just 1. It's a whole equation. All right, guys, your axis of symmetry is a whole equation. Your vertex is just 1 point, right? But your axis of symmetry is a whole equation. X equals 1. Now, guys, looking at this graph, is this going to be a minimum or a maximum? A minimum, because it's the lowest point. Very good. And our lowest value here is also connected to the vertex at -9. Okay? Now, what is our domain in this kind of situation, y'all? Yes, all real numbers. That's kind of a given. And then our range is directly connected to our minimum here. And so, guys, that would be y. Is it greater than -9 or less than -9?
Great.
It's greater because everything is bigger than the minimum. Greater than -9. Now, I also want to go ahead and add a little extra thing on here. All right? Where I'm going to ask for the roots. Okay? Now, the roots are the values of your x-intercept. Okay, guys? So, what are my x-intercepts here? -2 and 4. Okay? So, we have -2 and 4. Do y'all feel good about that? Now, guys, if I asked for the x-intercepts, then we would have written that as -2, 0, and 4, 0. We would have written it as 2 points. Does that make sense, y'all? So it depends on how we ask for it. The roots are the values. The x-intercepts are the actual points. All right? All right, so guys, honestly, we're just identifying these right here. So let's take a look at this second one. Guys, where is my vertex on this second one? 0, -4. Excellent job. And guys, once we have the vertex, what does that help us find? Like everything else, doesn't it? So guys, can we use our vertex to help us find the axis of symmetry? Yeah. So my axis of symmetry would be x is equal to what? 0, because the x value. All right. Is this going to be a minimum or a maximum? Minimum, because that's the lowest point. And our minimum would be here at -4. My domain is still all real numbers. And my range is going to be connected to our minimum. So are they greater than -4 or smaller than -4? Greater. Greater than or equal to -4. Okay? And then, just even though it doesn't say it, I'm going to go ahead and put it here. I want to know, what are my x-intercepts? Well, we have 2, 0 and -2, 0. Okay? So we can say -2, 0 and 2, 0. Are y'all comfortable with that? Now, one thing that I want you guys to pay attention to that's pretty cool about these graphs, okay? I'm going to zoom in way on this one, okay? I want you guys to look. Look at my 2 roots here. Look at my 2 points. Do you see how they are perfectly symmetrical across that symmetry line? So that's 2 points away, and that's 2 points away. All right, check this guy out. This one's 3 points away. That one's 3 points away. So y'all, every point will have a symmetrical counterpart on the other side of the axis of symmetry. So I just want you guys to see that there. All right, now let's look at this guy. So can we identify the vertex in this last graph?
Is it 4, 9?
Yeah. Yep, -4, +9. Excellent. Okay, so once we identify that, can we recognize what our axis of symmetry is, y'all? What's it going to be? Okay, but what if I ask you, what is the whole thing, though? X equals -4. Y'all, if I ask for the axis of symmetry and you just say -4, that's wrong. The axis of symmetry is an equation. So make sure you type in an equation for your axis of symmetry. All right, guys? So it's x equals -4. Now, is this one going to be a minimum or a maximum?
Maximum.
A maximum. And our maximum is way up here at +9. Our domain, again, is still just all real numbers. And our range is going to be y. Is it greater than 9 or less than 9? Less than or equal to 9. You guys are correct. Less than or equal to 9. And then, what are my x-intercepts in this case? Ooh. -1, 0. What is that one? 1 and -7. So -7, 0 and -1, 0. Okay, guys? And so those are 2 separate points. And you'll notice again, are my x-intercepts perfectly symmetrical? They sure are. All right, guys? So that's just a good example of how you can identify some of our key features. Do y'all feel good about that? Excellent. Okay. Now we're going to jump over, and we're actually going to be graphing, okay? So now we're going to jump over, and we're actually going to be graphing, okay? Hold on just a second.